a research design in case of hypothesis testing study, two things which you have to remember. The first thing is such study always will be trying to establish a relationship between variables. That is, we are establishing the relationship between two or more variables. Maybe you have 6 to 7 independent variables and one dependent variables. For example, in marketing studies, the general thing what we will be studying is what are the factors that are affecting the customer satisfaction. In that, you might be having many independent variables like the product quality, the product price, the packing, the availability, the customer service. All that will be factors contributing to customer satisfaction. So we are trying to understand how are these factors contributing to the dependent variable called customer satisfaction. So there is a causal relationship that has been established between variables. That's one type. And of course, in case of hypothesis testing or experimental studies, there will be the testing of the relationship. How far it is related, how far the factors like pricing or quality or customer satisfaction, customer service affecting the satisfaction level of customers. So there is a dependent variable, that is customer satisfaction. There are many independent variables like quality of the product, price of the product, or maybe when we are looking at it can be the service offered, availability of the product, or optional variety being provided in that product category, right? So all that independent factors. So you are trying to find out which is having more impact on customer satisfaction, which are the factors that are considered to be more significant when we are measuring the variable called customer satisfaction. So such type of relationship establishment always will happen in case of hypothesis testing research studies. So that is first thing which we have to understand when we are going with a research design in case of hypothesis testing study. Now, these principles are very important. Listen to me very carefully. There are three basic principles that would be guiding the experimental designs. That is, experimental designs are nothing but where we are trying to establish a relationship between the dependent and the independent variable, and we are trying to test a model or a relationship between different variables. The three principle is, first, this can be asked individually in a university exam for theory, small like theory, like 5-mark questions and all. You might be able to explain that with examples, right? So there are three principles. The first one is principle of replication. Second one is principle of randomization, and third one is principle of local control. Now, what you have to understand here is these three principles, in fact, regulate the quality of the research output in case of experimental design, or they try to minimize the error, the statistical error, or the occurrence of residual errors in case of an experimental design. They try to minimize that through these principles. Now, principle of replication. I have put in brackets the keyword which you have to remember. That is, the same experiment is replicated. It is repeated more than once to ensure the result. It is said that every time, whenever I go with in the same sample, in the same conditions, if I conduct this experiment, I should get the result. That's what I'm trying to prove through repeated experiments. Maybe I conduct the same experiment, I conduct the same study in different contexts. I'm repeating the experiments to ensure that I get the same result. The example which I was quoting just a few minutes before, the impact of different factors on customer satisfaction. Say, I want to see, if I want to make sure that, yes, price is one factor that is affecting customer satisfaction. If I have to bring that as a independent and dependent variable relationship, I have to test it in different contexts. I have to test with different areas, maybe the same product in different contexts, so that I can conclude that, yes, price is a significant factor affecting the customer service. So that's what we mean by the principle of replication. If you ask me to say that in one word, the experiment is repeated many times to ensure its result, to ensure uniformity in its result. That's what the principle of replication. Now, the next one is principle of randomization. Principle of randomization, I have put the keyword, what you have to remember, the chance factor. That is, we said that in every study, there would be many extraneous factors that are affecting the result. But fortunately or unfortunately, we may not be covering the entire thing in our study because we have some limitations like resources like time, money, or maybe no, the other favorable factors. All that would be our scarce resources. So if we are trying to include all of it into one study, we may not reach anywhere. We may not reach to any conclusion. So in order to conduct a good research, in order to come to a meaningful conclusion, we might avoid certain factors, certain extraneous factors, which we know that they have some kind of effect on our study, but we are not covering that in our study. The principle of randomization help us to minimize or no, to nullify the impact of that extraneous factor in our study, because we are picking the sample at random. We are collecting data at random. So the occurrence of extraneous factors are minimized through randomization. We are not purposefully manipulating the data, no, so that the impact of extraneous factors cannot be, or maybe can be. It can be, cannot be, or can be studied. We don't want it because we are not including extraneous factors in our study. But principle of randomization help us to minimize the impact of that. Because say for example, suppose if I'm going to study the impact of training, okay, impact of training on a particular category of students, but I know that one factor that will affect, no, which is not, I'm just looking at what is the kind of impact of this particular training on the student community. But I know that the IQ level of a student is one factor that may affect the quality of the training. That may affect, because see, I would be discussing many things in the class. The absorption level of each one of you would be different. Some of you will get more than what I'm talking. Some of you may be taking little time to cope up with understanding what I'm talking. Right. So that depends on each one of our IQ level. So same is the case here when I'm trying to measure the impact of training. There can be one factor which I've not included in my study, the IQ level of student. Right. So that is one extraneous factor which can affect the quality of the training. Some students may perform very well if their IQ level is very high, if they can absorb all what is being discussed in the training very well. So in order to minimize that, what I will do is I will pick students from different disciplines at random. At random. There is principle of randomization. I'm not going with only the student community, those are going with mathematics. No, we say that they are supposed to be with good IQ. May not be, there is no, it may not be true, but for the time being we consider that okay, these students, or maybe those students who are scoring more than 80%, if I pick those students alone and measure the impact of training, sometimes it might be good. But there is some error because I have manipulated my sample. I have picked purposefully. That's what we call as purposefully sampling. I have purposefully picked few to bring the result as the training has a significant impact on student community. But if I'm going with randomization from students, if I'm picking students from different discipline, that I'm just minimizing the impact of extraneous factor called IQ level of student. Because when I'm picking at random, there are possibilities that students of different IQ levels will be part of my sample from the, or selected sample from the available population. So that is what I call as principle of randomization. I am just depending on the chance factor. Every unit of the population is given with a chance of being selected as the sample. That's what we call as principle of randomization. And that can also reduce sampling errors. Okay. Now the third principle, principle of local control, it's actually something which we do to minimize the variability due to extraneous factors. Say, for example, the best, because this experimental designs have originated from agricultural research. They had its basic origin from those researchers that are conducted in agricultural science. Right. So the very good example which I can say for principle of local control is I'm trying to understand the yield of a particular seed. Okay. I'm trying to understand the yield of a particular seed by planting it in different parts of different parts of my field. Right. Then there is one factor which is a significant extraneous factor which is going to affect the yield of my what I call seed, the yield, which is going to affect the yield. That is fertility of the soil. If I have planted all my seeds in a fertile area, the yield is going to be very high. Right. So maybe I cannot say that this particular seed is of good quality, the yield is high, because there is one significant extraneous factor which has affected this particular result. So for me, what I can do is, I know that there is an extraneous factor which is called as soil fertility. I know that that is there. So in order to minimize or eliminate the impact of that extraneous factor, what I will do is I will make the land, or I will divide the land into different segments based on the fertility level of the soil. I will consider that as an extraneous factor. In order to have some kind of local control of that extraneous factor, what I do is I divide my farm entire field into different segments, different small fields, right? And then I put my seed over there and see whether the fertility of soil is a factor, because I will check what is the yield of this crop in maybe portion A of my field, in portion B of my field, in portion C of my field, portion D of my field. And I know that the fertility level of the soil is different from of A and B is different. B and D is different. I have brought a local control to minimize the impact of the extraneous factors. So that is what we call as principle of local control. See, I will talk the example of one of my research scholar. She is doing her research in coastal tourism. Okay, coastal tourism. Now, as we know, the type of coastal tourism we have across Kerala is different. The type of activities over there, the games or the facilities over there, the infrastructure development, the government initiatives, many things vary from one location to another. So what she knows that there are many other extraneous factors that will affect the quality of coastal tourism destinations in Kerala. So what she has designed is, she has formed clusters, different coastal tourism destinations put together depending on the availability of facilities, the type of games, the type of infrastructure facilities. And then she is looking at what is actually the customer satisfaction, tourist attraction, the impact on government revenue because of this coastal tourism initiative. So she has brought a factor called homogeneous classification. There is heterogeneity across coastal tourism destinations within Kerala. She's trying to bring some kind of homogeneity in this heterogeneous group by applying the principle of local control. So that's what we call as the principle of local. These three things are very important for us in case, especially with respect to those researchers that are dealing with hypothesis testing or establishing causal relationship or trying to study the relationship between dependent and independent variable. So these are the three principle of replication. The keyword which you have to remember is repeated experiments to minimize or to ensure the result. To make sure that you have similar results or same outputs coming up. Right. Then principle of randomization, choosing at random, not manipulating the sample, so that the chance factor is brought into our study, so the impact of extraneous factors can be minimized through this chance factor. And principle of local control is heterogeneous groups. In such study, there is some kind of local control is being brought in by introducing the concept of categorizing the group on the basis of some kind of homogeneous characteristics. And you are picking equal samples from each homogeneous group so that you can study in a better way. You can understand the scenario, you can understand the relationship in a better way. So these are the three principles that are applicable with respect to a experimental design. Now, there is one more thing which we are going to discuss in our today's class. The next one is experimental designs. We can classify that broadly into two categories. Okay, two categories. The first one is informal designs and second one is formal designs. Now, informal designs generally is followed in those researchers that do not require much sophisticated output or much that do not have much sophisticated result expectations. Maybe a preliminary study, maybe a casual understanding of relationship between two particular aspects, two particular variables. And if that is proved, such researchers are taken up to the next level where we go with some of the formal designs to prove or disapprove a particular aspect, a particular relationship. Now, so as I said, experimental designs can be categorized into two, informal and formal designs. Today we would be discussing about the informal designs. Okay, it's very easy to understand. Just listen to me very carefully. Informal designs, there are three types. One is before and after without control design. Then the next one is after only with control design, and the last one, which is supposed to be the most sophisticated one with respect to informal design, that is before and after with control design. Now let's look at what it is. This is, I always, before giving any theory part, it is very easy for us to understand this design by looking at here, this formula. This is very easy for us. Actually, here, the example which I was telling, I was talking about the impact of training on student community. Okay. So, what is happening here is you select a group of students. Okay. You measure their, suppose if there is a training which is given for their interview skills. Okay. A training is given to evaluate their skills or the ability to perform well in an interview, right? You measure their ability to perform in an interview before the training. That's our first step, okay? Before the training. Then you give the same set of students as with us, okay? You give the student the training. You introduce the training to the students on how to perform well in an interview. Okay. And then you measure the ability after the training program. I hope you're getting me. First, you measure the ability of students to perform in an interview. You measure it, you keep it, you keep the questionnaire. If it is through a questionnaire, you keep it ready. You evaluate it, you keep it ready, the results with you. Then you give them the training, okay? The training on how to perform well in an interview. Finally, after the training, you conduct the same test again and try to evaluate what is the difference that has happened with respect to their performance, the skills with respect to the skills of performing in an interview. So your net result is you want to test how effective is this training for this particular group of students. So what you will do, you will actually, you have the first result, you have the second result. The difference between the second result and the first result. If suppose, if no, we always anticipate that there can be some kind of improvement in the students, right? So the difference between the second result and the first result is something which we are going to do with for measuring the effectiveness. This is something that is really happening in social science research. If I want to know what is the impact of I'm undertaking, actually, if I have to conduct what is the effectiveness of my class on research, how far you are able to do a good research. First, I should have been done a test where I will just ask you your awareness regarding this, no, the research and the aspects, what are the important things, the research process, all that. I will conduct a study, entry level test. I will conduct that. I will keep the result. After my course, I will conduct the same test again and I will make a comparison whether you have improved or not, whether your results have improved or not, whether your understanding on research has improved or not. If there is an improvement, I can assume that there is some kind of improvement that has happened because of my research, because of my research classes. So that is what we mean by this before and after without control design. Now you have to remember this, before and after without control design. Why without control, which I'll explain in the next thing. Okay, in the next design. So this is the first one. So the difference, the effectiveness of my class can be measured by the performance of the student after the class and before the class. If there is a difference, if after class the student became more competent, I can assume that yes, there is some kind of impact of my class on the awareness about social science research in this particular student group. So that is what we mean by before and after without control design. Why I speak with examples, later when you are reading through your textbook, don't learn it just by theory. Please try to understand, try to inculcate the possibilities of you or conducting different research in using this research design. There are different designs what's been discussed, which you can think of when you're doing your PG project. Okay. Now the next one, okay, here you will understand what is actually the control design. Okay, so here you have a controlled area. Okay, in this particular group, what you are going to do is you have two groups. Okay, you have two groups. You have two groups where you have one is controlled area, another one is test group. So there would be, we are 30 in our class. Okay, we are 30 in our class. I'm going to divide you into two groups. 15 students, one group, another 15. I will call that as control area. Now I'm going to give my class only to the 15 students. 15 among you. I'm going to give my my understanding on research. I'm going to discuss. I'm going to make you do few exercise. All these happening to 15 students. The other 15 are left with no such treatment. They are not given with any classes. Now I'm going to try to measure the effectiveness of my class by comparing between the two groups. One group, the test area, 15 students where the treatment is introduced. In our class, a class on research methodology and level of phenomenon after the treatment. So I measure phenomenon after that. What is the kind of awareness after this class on research methodology? And there is another 15 students who are given with nothing, no orientation on research, no class on research. I measure their performance. Now I'm going to compare the performance between the students who are undergone the treatment with those who did not have any kind of treatment. So that's how I'm going to check it, the difference. If there is a difference, I can assume that yes, there is some kind of value addition that has happened because of class on research methodology. If there is a difference between these two groups, because I assume that these 30 students come from homogeneous community, homogeneous group. If I'm taking from different like heterogeneous category, maybe 15 I took from science background students and another 15 from maybe economics background students. It is a heterogeneous group when we are looking at this particular concept of understanding of research. It's a particular because the research, the principles, the even though the aspect remains same, how they practice it varies between the science and social science students. So my group picked basically in the example where I took from economics and maybe some from physics. It's a heterogeneous group. I cannot do that. That's why I specifically mentioned I took from my PG class who are pursuing their PG in commerce. I divided that into 15, 15, right? Assuming that they are a homogeneous group. But there are many other heterogeneous factors. Maybe your understanding from your undergraduate program. Some of you might have had extensive class on research. Some of you may not have any class on research. Right. So that is there. Those are the extraneous factors. So I pick at random just to minimize the variability. Okay, just to minimize the impact of extraneous factors. And then I'm trying to give my research orientation to 15 students. The other 15 students are left like that. Then I'm trying to measure the effectiveness of my research class by looking at the performance of these two groups. The first test group and the control group. Control area, control groups are given with no test. They are given with no treatment. That's the concept of control group. Last example, I said this is without control group. There is no control group because everyone is given with the treatment. But here, there is only one group who are given with the treatment and the next, the control group, the other group is left without treatment. So that's why with control design. I hope you understand the concept of that control design. Now, this is the difference between the performance of the control group and the test group is evaluated to know the effectiveness of a particular program. I just said training, it can be anything. It can be anything. Maybe it can be financial literacy program introduced by the government. It can be employment support initiative of the government. Anything. It can be. You are looking at what is the impact of that particular scenario on the respondents, right? And the last thing what we are going to discuss today, this is actually a really sophisticated model which follows the principle of replication, which follows the principle of local control, also the principle of randomization. Here also, before and after with control design. Here you have test area and the control area. That is, you have test group and control group. You measure the performance of these two groups before the introduction of the treatment. Okay, you measure it, you record it, you analyze it. Then treatment is introduced to the test area. Okay, and then you measure the result after a particular time period. Maybe you say that a treatment is introduced. The very good example here you can look at is the effectiveness of COVID vaccination, right? You can see how far it is effective by conducting this research because some of you are already given with the vaccination. Some of you do not have any vaccination. So one can be the control area, which the people who do not or who did not undergo any vaccination. And the test area are people who went with vaccination. And you can see the impact of this vaccination by keeping a time span, maybe 1 year period or 2 year period, within 2 years. How far the person is protected from the attack by the virus or attack by the disease, the pandemic called COVID. Right. So that is possible. So here what happens here is you record the before performance of two groups, that is the test area groups and the control groups. Then you introduce the treatment only to see you. It is easy for you to remember this COVID vaccination. You introduce or you give vaccination to the test area people, to the test area group, and then you look at the performance after 1 year. After 1 year, you look the performance of both those given with vaccination and those not given with vaccination. But one thing you have to ensure is that the group is homogeneous. If you're taking people from different age groups, you may not be able to come to some meaningful conclusion. If you're taking, so there are many other extraneous factors. People having diabetes are more prone to this particular disease. People having some asthmatic problems are more prone to these diseases. So likewise, there would be certain extraneous factor which we have to nullify the effect by principle of local control. That we have to do. So here what is happening here is you will look into what is the result y minus x for test area minus what is the result for control area, that is z minus a. So the difference, if there is no difference, we say it is not effective. If there is a difference being shown by these two groups, we can say that yes, if these people are less affected, if the test group people are less affected by COVID-19, we can say that the vaccination had some kind of impact with respect to controlling the respondent being affected by the particular disease. So that is what we call as before and after with control design, which is considered to be the most sophisticated method among all informal experimental designs. Right. So I'll just quickly summarize. Today we had a little, few important concepts which we discussed, which you have to remember always. Okay. So first we started with what is an experimental design or hypothesis testing design. Here, in case of experimental design, always there is a causal relationship that is established between the what we call as the dependent and the independent variable. So there is a relation being established. Such type of research design we call that as experimental design. Such designs had its origin from science, agriculture science, and we broadly can categorize these designs into two groups, that is informal and formal designs. Today we discussed about the informal one. Informal one, there are three categories. The first one is as we say here before and after without control design, and the second one is after only with control design, and before and after with control design. That is the last one which we said. So the control factor is absent with respect to the first one, that is before and after control. We are selecting a homogeneous group. First we measure the performance before the treatment, then we introduce the treatment, we measure the performance after the treatment, we make a comparison between after performance and before the performance before the treatment, and if there is a change, we look at from the angle of the effectiveness or what is the impact of that training or the treatment. It can be medicine, you apply a vaccination, it can be medicine, or maybe it can be that you go with some kind of counseling. You want to see the impact of counseling on an alcoholic patient. That also, the psychological research generally do this type of studies. So that is possible. Now the next thing what you have to understand here, there are two groups, the test group and the control group. Test group is given with the treatment, control group not given with the treatment. And here you are measuring the result only after the treatment, not before that. So that's the basic difference between before and after control design and after only control design. You are measuring the result only after the treatment. So that will be Z minus Y, right? And the last one is before and after, means you measure the performance at the beginning before the treatment. Here also you have two groups, the control and the test groups. You measure the performance before for the test group, you introduce the treatment, then you measure the performance of both the groups after the treatment, after a stipulated period. You imagine the example which I said about vaccination, COVID vaccination. It will be easy for you to understand. So that's it. Now what you have to do is you have to read our texts very thoroughly, because normally these research designs are really helpful when we are planning for our research.